Hi, everybody. Welcome to my home. Today, we are going to be in my home because I was not able to get to school today. So, we are going to do some standard form. We are in lesson 5.7 of our module 5. So, we're still working on linear equations. In this particular lesson, we are going to go through 3 videos. This first one is just talking about standard form and what it is. Our second video will talk about the pros and cons of standard form because there's definitely some limitations to this format of equation, but there's also some major benefits to it. And then last but not least, we will look at how to convert an equation into standard form and out of standard form. So lesson 5.7, standard form, video number 1. So far we know how to deal with slope-intercept form. We know what it's all about. We can look at slope-intercept form and say y equals mx plus b. The m stands for, hopefully you're shouting, slope. That's super tiny. I wrote that super tiny. I'll write that way bigger. Here we go. Slope. And the b stands for the y-intercept. And it's great. It's fantastic for graphing equations. It's so nice. Initially, we can find the where it starts on the y-axis, and then we can use the slope to do rise over run, and we get a really good sense of the ratio of rise over run and like how the changes in y's versus changes in x look on a graph, and we can really like sort of embrace what a linear equation is all about. The problem is, though, it only works for certain situations. If I were to put this in real life context for slope-intercept form, I would be talking about something like I go to the post office and I take a package to the post office. I have to pay for a flat rate of whatever the post office is going to charge no matter what if you send a package. And then after that, they charge per ounce or they charge per pound or half a pound or whatever the post office figures out for their situation. Or it's a situation where if I were a gardener and I were going to go to somebody's house and actually work in their yard, and if that person were to cancel their like reservation with me as soon as I drove up to their house, I'd probably want to be charging them at least a little bit for the inconvenience of coming to their home and then being canceled on. So a lot of contracts that exist out there have sort of stipulations. You pay per hour, but no matter what, you're going to be paying this base flat rate, which sort of takes care of their liabilities that they have going on, their insurance and that sort of thing, that sort of are always sort of expenses for any business. So this is a really common practice to have sort of a base rate and then a rate per hour that they charge. That's great, fine and dandy. Well, what if we had a situation like this? I go to a taco truck. I am buying food for my whole family. I have $20 that I'm going to spend. I want to spend $20 because I want to support this taco truck. If they have tacos that are $2 and drinks that are $1.50, I'm not necessarily going to be looking at this situation and say, okay, here's my ratios of tacos versus drinks, and say, like, I can buy 2 tacos for every 1 drink, and I'll have $4 worth of tacos and $1.50 worth of drinks. That's a super awkward slope. Instead, I'd likely write an equation something like this. $2 for each taco plus $1.50 for each drink is going to equal $20. So what different amounts of tacos could I purchase? What different amounts of drinks could I purchase to use up that $20? So I could say, like, I'm going to have 10 tacos, no drinks, spend $20, right? I could also say something like, I could have 10 drinks and 2.5 tacos. Ooh, that's super awkward. But maybe 9 drinks and 6 tacos is less awkward, or whatever the number is. I haven't figured that one out. Either way, we are looking at a situation with this sort of problem that is more applicable to a different type of linear equation. This is still a linear function, just like this is a linear function, but it's set up differently because it deals with a different type of context or problem. So this format right here is what's called standard form. Standard form looks like this. AX plus BY equals C. This B, notice, it's capitalized. It's different than this B. This B right here is not my y-intercept. As well, I do not see an m in here, so we're not talking about slope anywhere. We would actually have to convert this into slope-intercept form to see what slope it really is based on the coefficient here and the coefficient here and the constant over there. We'd have to really like do a bit of manipulation, which we will do in video 3. There are some major limitations to what numbers you can put for your A, B, and C in standard form. One limitation for A, actually, A has a lot more limitations than B and C. A has to be a positive integer. So, and a positive integer, I should say, greater than 0. If I put 0 in here, I automatically don't have a, I have a linear function, but it's a horizontal line. The slope is taken away, so now I just have a horizontal line. So it's a linear function, but it's not nearly as robust as some of the other equations we've been dealing with. Either way, A has to be a positive integer greater than 0. So 1, 2, 3, 4, all the way up to positive infinity. It could be a million, I don't care. But it needs to be a number greater than 0, and it can't be a fraction or a decimal. If we then look at B and C, these also have some limitations, but they have a little bit less of a limitation. The limitations for B and C are these. It needs to be an integer, and that's it. It needs to be a positive or negative number that essentially we can count. So like all the numbers on my fingers and my toes, 1, 2, 3, 4, all the way to positive infinity, and their opposites. In this case, C could totally be 0. Now, B likely will not be 0. If B was 0, we would not have a function anymore. We'd have a vertical line. However, technically, we could still write this in standard form. The B would just be missing, right? And we'd have 0y or nothing left there. But A has to be a positive integer greater than 0. B and C need to be integers. So they just have to be positive or negative numbers. Notice, none of this allows fractions. And that's a big part of standard form. If you have fractions, you're not in standard form. So if this has 1/2, you need to multiply everything by 2 to get rid of that fraction. So we're going to play around with that in video 3, but I just wanted to give you a heads up about what standard form is all about. So 2 more videos after these 2 videos, then you can start working on your must-do practice problems, and you can play around with standard form. It'll be fun and dandy. Yeah?